Hi, a very good morning to all of you. Can anyone please confirm whether I'm audible or not so that we can proceed?
Yes, sir, audible.
Yeah, okay. So, good morning once again, all of you.
Good
Welcome to.
morning, sir.
So, myself, Gaurav Gupta, on behalf of RX Tech Solutions, welcomes you all for this 5G course on which we have enrolled. So, basically, not to wait anymore. I think enough people are there. If other someone comes, then he will be welcome to join. So, let's start with this. So, basically, give me a moment. So basically, this training module is designed for 5G optimization training, all those stuffs, where you will be made walk through what is the technology 5G, what will be its architecture, what are the deployment options. I mean, the mechanisms with which the technology being rolled out in the market. What are the KPIs to look upon? What are the thresholds? Depends on operator to operator. What are the issues which we encounter in terms of KPI optimization and how to troubleshoot them, irrespective of the drive test. How we gonna troubleshoot them through the counter and parameter optimization specifically for 5G. And in this batch, I can see, around 16 people are there. I'm sure that most of you already aware of our traditional black and white concepts of traditional technologies like 2G, 3G, especially talking about LT, 4G. So I hope having that basic fundamental or expert knowledge, you guys have enrolled for the 5G course. So time to time, I'll just touch the basics of 4G as well. It's not like that I'll be focused on 5G itself, so that you will not feel anything different, because this is technology. Many of the things are interrelated to each other. Many of the things, will be new. The terms will be new, which will be taking the names again and again repeatedly. So all of them, I'll made you a walk through. So let's start with it. Let me share my screen. So just confirm me whether once my screen gets visible to all of you. Anybody can confirm whether the screen is visible to you all.
Visual, sir.
Okay, thank you. Thank you so much for confirming. So basically, as I told you, we'll walk through with the 5G RAN architecture, the deployment modules, the KPIs concept, and advanced troubleshooting. And we will also make you walk through the OSS, basically how to log into a particular site. What are the commands for it, to checking various stuffs like cell status, alarms, ROP-wise KPIs, the KPIs trend, and the issues which are being encountered. How to do the parameter optimization for all those stuffs already included in this training module. So this 5G optimization course, we have divided this entire course into a total of 6 modules. So we will go module by module. Total of 6 modules to start with. I mean, today I'll be covering this module, first module, which will be based on the 5G architecture and performance framework. Then we'll proceed for module 2, which will be accessibility optimization. Let me put this in presentation mode, sorry. After module 2, we'll be proceeding to module 3, which will be for retainability optimization, basically the drop troubleshooting and all that. Then module 4 will include the mobility optimization, basically the handover statistics, what are the challenges that are being encountered in handover stuff, how to optimize them, how to troubleshoot them, basically. Then we will go for the throughput optimization, which is one of the very critical part, talking about either for 4G or 5G, because the user and experience should be at par, as excellent as possible. It's a very high competition among all the operators to deliver the best-in-class service in terms of the downlink speed. All operators are fighting for delivering. Some operators are saying, okay, we are going to provide this much of Mbps. Other operator will say, no, I'll provide in Gbps. So that all stuffs. What are the basically ground reality issues which are being encountered for throughput optimization? So module 5 will be covering all those stuffs. And last but not the least, the module 6 will include the end-to-end performance and troubleshooting. This end-to-end, after covering all the KPI part, we will be taking a workflow for this RACH optimization, RRC optimization, NGAP and DRB optimization. And I'll be showing few of the live, case studies. What are the case studies that are being encountered in 5G in terms of any KPI, in terms of other challenges. We also have the voice over NR, because you might have heard that 5G technology don't have any service for providing voice services directly. So it is called as VONR, voice over NR, voice massive connectivity, and URL LLCC. So basically, live case studies will be covered in the module 6. So coming back for the module 1, today we'll be covering the module 1, that is your architecture and performance framework. Architecture and performance frameworks, this module, this first module, is covering a total of 7 topics, starting with the RAN overview of 5G. Then we will be covering the core network elements like AMF, SMF, UPF. I'll just explain you one by one. Then the 5G interfaces, then going upon the 5G functional splits, the CU-DU and the CUPS architecture. Then we will be having some basic key parameters like bandwidth, TDD, MIMO, sub-carrier spacing. Then we will be covering our deployment options, the mechanism, the strategies by which the 5G being rolled out in the market, commercial market. And last but not the least, the performance KPI, means accessibility, retainability, mobility, and integrity. So let's start with the module 1, first module. This is nothing but the same slide. So basically, you people might have gone through the basic concept, the basic difference between 4G and 5G. Wherever the architecture of 4G is kind of a fix, it is flat hardware-based architecture. While if we talk about the 5G architecture, it is like cloud-based. It is cloud-based or service-based architecture. Like we can say, like cloud-native virtualized-based, cloud RAN or edge computing. You might also heard about the word as edge computing. So all these terms comes under the 5G technology, and it is not any fixed kind of architecture. Like LT is for 3G, both are for 3GPP release. 3GPP release 8 to 14 comes under LT, and beyond this 8 to 14 it comes under 5G, or we can say it as LT Advanced Pro 5G. 5G is a term, but in actual it is LT Advanced Pro. Talking about this spectrum and frequency range, LT of sub 6 gigahertz of range, mainly below we can say LT comes under below 3.5 gigahertz. While 5G we have 2 frequency ranges. One is FR1, another is FR2. FR1 comes under less than 6 gigahertz, while the FR2, basically FR2 is called as millimeter wave, wave. This is like 24 to 100 gigahertz, basically. We will be providing you the PPTs or the notes, essential notes, after every session. So please just be relaxed on that. You are not going to miss anything. Any of the critical term, something like that, I'll be mentioning in chat. But apart from that, critical notes or PPTs will be shared from RF Tech Solutions to all the participants after the sessions. So proceeding further, talking about the modulation schemes, LT, we have this QPSK 16 QAM, 64 QAM, but in 5G you have the higher modulation schemes like 256 QAM as well. Basically, sub-carrier spacing, if you talk about, LT has a fixed sub-carrier spacing of 15 kilohertz only. While we have multiple options, we have a leverage in 5G where we have a flexible carrier subspacing like 15 kilohertz, starting from 15, 30, 60, 120, and 240 kilohertz, basically. So basically in the 5G architecture, we have split mechanism. I'll be covering it further. So start with the core components of 5G RAN. Give me a moment. So these are some of the core components of 5G RAN. 4 core components we can list. First is the G node B. Second is the central unit or CU. Third is the distributed unit or DU. And last is the radio unit or RU. So starting with G node B. G node B is nothing but we can say like in 2G, you might have heard the BTS, base transceiver station. LTE it was E node B, and generation next in 5G it is the G node B. Basically it is the base station only, nothing else, which is further split into centralized unit CU and the distributed unit DU. Here in 5G, the base station is split into 2 components. One is central unit and one is distributed unit. Now talking about the central unit CU, this centralized unit is further split into 2 components. One is CUCP, that is Central Unit Control Plane, and another is CUUP, Central Unit User Plane. So basically, this is typically placed in cloud or central data centers. Physical unit, which is your radio unit, which is placed on the tower top, which performs all of your RF processing, like amplification of signals, massive MIMO antennas. It supports. So it goes like that. Here, just a simple architecture. Basically, the idea of this slide is to compare, the 4G architecture in a very crisp, in a very short manner. This is not a detail. This is just to give you a basic idea. The difference between, 4G architecture, 4G basically, 4G lag and the 5G lag. In 4G, you can see only we have one front hall as well as the back hall. But talking about 5G, 5G has mid hall also. The front hall comes in between the interface between DU, RU. The back hall is, the CU, the centralized unit connected to the core network, 5G core network with the help of the back hall. While we have introduction of mid hall that comes between the DU and the CU. So we have an additional interface, which is called as mid hall, only in 5G and not in the 4G. Now we will be discussing one by one of the component of the 5G RAN, that is G node B, CU, DU, RU. So let's start with the G node B basically. So as I told, this G node B is nothing but the 5G base station, which is equivalent to E node B in the LTE. But unlike LTE, the G node B is split further into CU, DU, and RU. So basically, the functions of G node B, as we know, is nothing special but the BTS of GSM or the E node B of LTE. It manages radio interface with the or we call as user equipment (UE). It handles radio resource controller, PDCP, MAC, physical layers. It is split across all the components. And this G node B is the component which supports your higher throughput and flexible deployments. I mean, when you're going to deploy your technology on cloud or edge, the G node B comes into picture. So basically, as I told, that this is not flat-based architecture, unlike LTE. It is cloud-based or edge computing-based. So it has the multi-vendor interoperability. So multi-vendor interoperability, because it is so scalable, that's why, the operational cost will be very less. That's why it is getting popular day by day. It has dynamic resource allocation, basically. So this is the basic functions of the G node B. Moving further, as I told, the G node B is further split into two components, CU and DU, and CU. Central unit is split into two more further components. That is CUCP, means Central Unit Control Plane, and another is CUUP, Central Unit User Plane. So why we are splitting it? What are the advantages and what are the basic difference between CUCP and CUUP? That we will be covering in this slide. So first talk about the CUCP, that is Central Unit Control Plane. See, this layer, this component handles all the signaling or control operations. It handles all the signaling and the control operations. And function of this CUCP component is radio resource control management, NAS signaling to core, mobility management, means it is the one who takes the handover decisions, and it carries the radio bearer control, and last the UV context management. So basically, broadly we can say that CUCP component handles all your signaling control operations. While talk about the CUUP, this component handles the actual data forwarding for user traffic, for the user part, for the data forwarding for user traffic. Functions, if we talk about, this is your PDCP, means PDCP layer, which controls your header compression, ciphering, security part and all that, and the integrity. The SDAP is basically QoS flow of DRB mapping, and the GTPU tunneling. So talking about PDCP, which is Packet Data Convergence Protocol, it handles your header compression, your security part, ciphering, and the integrity. And SDAP, as I told, it is for the QoS flow based, and GTPU tunneling, which is basically interface with the 5G core user plane, UPA. So both of these, both of components are typically they are deployed in the central, they are deployed in the cloud data centers, which enables your resource pooling. They have the easy maintenance, and very cost effective. So basically that's what we were discussing, like operational cost for any particular operator will be very less. Now, what is the interface which connects CUCP to CUP? I mean, both of the components are connected by which interface? So that is E1 basically. The E1 interface is the one that connects CUCP to CUP or CUP to CUCP, vice versa. It basically further take care of the coordination between the control plane and the user plane. So this is for the CUCP and the CUP. Moving on to the next component, these are the benefits basically: independent scalability, flexible deployment, network slicing agility. Slicing I'll cover later on, but let's go with the components first. So this is our third component, which is distributed unit DU functions. So what is distributed unit and where it is located? So distributed unit, this is located in the cell side. Basically, we can say that often at the edge cloud or the aggregation side. This is located near to the cell side. So what are the functions of the DU? Basically distributed unit. So functions of distributed unit we can enlist as MAC scheduling. Second is RLC, AMUM. Parts of the physical layer. This DU is the one which handles your hybrid ARQ, ARC, basically we can say. It handles your beam management. It handles your time critical scheduling. And this DU, it communicates with central unit using the F1 interface. So the interface that connects both central unit and the distributed unit is the F1 interface. I can write on the chat book, but better that you guys have the slide deck after this session. So if you want, I can write. Rest, be relaxed. All the slide deck will be distributed to all the participants. And so DU, we can say that DU is a very critical component. It handles the low latency operations, which are having the, in which the low delay is acceptable. So for the low delay operations, the distributed unit comes into play, comes into picture. The interface is already, as you can see in the right side, it has been written. This F1C, this is the control plane signaling between CUCP DU and the F1U. This is the user plane data between CUP and DU. Everything is written over this. So basically, critical role also I have mentioned in this slide at the bottom side. So it is situated close to the radio side or the cell side, which handles your time critical functions, which makes it essential for achieving 5G's low latency performance. That's what we are talking about. So this is for the DU, the distributed unit. Moving towards our last component, that is your RU, the radio unit. So radio unit, what is it, where it is located, and what are the basic functions of a radio unit? So this radio unit, RU, this is located at the tower antenna. You might have seen near to the antenna, one rectangular, hardware boxes, small size boxes are placed. They're heavier in size. So there you can find your radio unit, which is placed at the tower and the antenna. So it is a physical part which you can see on a cell side, on a tower, to the antenna, below to the antenna. You can easily see it physically. Basically, the compact radio unit hardware box. The function of the radio unit is for the RF processing, amplification of signal, filtering out of signal, the conversation between the users. So we can encapsulate this term as RF processing. It handles your lower physical functions, FFT, fast Fourier transform, or IFFT, lower physical functions. And this radio unit is the one which supports your massive MIMO antennas. You guys have heard about the MIMO, multi-out in the LTE. In 5G, we have massive MIMO. So basically, it is the component radio unit is the one which handles your massive MIMO. So this RU, the radio unit, it is connected to the distributed unit with front hall. As I told in the architecture diagram, front hall, mid hall, back hall. So basically, the front hall is the one which connects RU from DU, basically. And it is connected to eCPRI. eCPRI also I'll be covering up. Let's go back to this previous slide. Give me a moment. Yeah, this is one benefits of CUCP and CUP separation. So basically, one question comes into the mind that this centralized unit we have distributed among two further components. One is the control plane, one is the user plane. So basically, what benefits we will achieve by splitting this central unit into two further components? Why we have done this? There should be a purpose for it. So speaking in a broader manner, we have a total of 5 advantages. The first one is independent scalability. Second is very easy deployment, flexible deployment. Third is a network slicing. Fourth is the enhanced reliability, security. And fifth is the multi-vendor support. What do you mean by independent scalability? Because you have split this control plane and the user plane. Because both planes have the different performance need, different requirements. So we have make them as the independent unit. So the scalability becomes very independent. The first one. Flexible deployments, a very easy deployment, a very cost-effective deployment. That's why it is getting popular day by day. Talking about this network slicing in 5G technology, you people will come across this term network slicing every now and then. I'm sure you might have heard that the participants who have gone through some fundamental theoretical concepts, you might have heard this network slicing. First of all, talking about network slicing, what is network slicing? Why you're using it? Why this is also getting popular? So network slicing is nothing but this mechanism. It allows the particular operator, to create multiple virtual networks on a single physical infrastructure. I'm repeating that again. This allows a particular operator to create the multiple virtual networks on a single physical infrastructure, which is designed for specific use individually. Unlike in LTE and the old technologies, no technology has this mechanism of creating one single physical infrastructure into multiple components, but 5G is the one which provides you this kind of leverage. And every independent virtual network is entitled to provide individual services that depends upon the service type. So for that, we use the network slicing. So splitting the CUCP, CUUP, it provides your network slicing agility. And talking about the specific requirements, you have created your independent virtual networks. Why you have created that? In order to support the services like ultra low latency, and enhanced mobile broadband, MMTC, these kind of services gets possible with the mechanism of network slicing. Fourth, it is the enhanced reliability, security point of view. It is more secure as compared with the traditional technologies. And of course, due to this so much of flexible deployment, scalability, multi-vendor support it is having. Because already this is cloud-based. It is not a flat architecture. It is not a hardware-based architecture. It is free. It is open. It is cloud-based. So it provides the multi-vendor support. So these are the few of the basic and the broader benefits of splitting the CUCP and CUUP further. So till now, we have covered this core components about the basic 5G architecture. Moving further, and before that, I just want this session to be interactive, not on a monotonous manner. So you guys, any of the doubt, any of the question which is coming into your mind, you can say in between. I want this session to be interactive. It's not like, I'm just speaking and you're just listening. Otherwise, it will be a very, tiring kind of session. So until these two topics, I mean the 5G RAN overview and the core network elements, any of the participant having any question in mind, anybody wants to add something?
Sir, what is beam forwarding?
Sanjeev is raising hand. Sanjeev, can you speak up?
Hi everyone. Good afternoon. Actually, I have two concerns regarding your module. First one, I have a request to, if you going to share the PPTs, is it possible to share also the video link, whatever we present now? And the second one, the module number 6, you going to teach us about all the problem related things, means throughputs or whatever. But my request, is it possible? Can you add on some features to enhance our things like a throughputs? Because every operators have a one departments, R&D departments or some SME departments to every time they're doing the features implement. So if possible, can you add on some few great features so it is easy for us to understand how they work like that?
Definitely, we will be adding features also because in 5G, rightly said, Many of the existing and many of the new features are getting rolled out. Trials are going on by different operators. And talking about the KPI optimization, the KPI optimization, when we'll be starting, we will be definitely covering not only the parameter tuning, but we will be covering the feature part as well. We will add it. Thanks for the
Thank
suggestion.
you.
The rest to ensure you
Thank you.
that those are
Thank
KPI.
And Sanjeev, you will get the recorded session as well.
Thank you. Thank you.
So can we proceed further? Can I proceed?
One more candidate asked something.
Who was that?
Okay, you can proceed now.
Okay. Going back to my slide. Again, putting in presentation mode. If anybody wants to ask something, please just speak out in between. I'll just stop. We'll try to answer a query before proceeding further.
Hi, good morning.
Yeah.
Yeah, this is Kalim.
Yeah, Glenn.
Yeah, actually, you have said that in 4G. So, control plane and user plane is separate, right? So, no NAS layer in 5G.
Sorry?
You have explained that control plane and user plane, like in 4G, right? Two parts.
Mhm.
So, in
Yeah.
control plane, NAS, RRC, PDCP, MAC, physical layers. So, no NAS layer in 5G. I mean,
No, the function of the control plane, user plane. Yeah, sorry. Come again, please. You're saying something?
yeah. In 4G, like NAS layer is separate for control unit, and remaining data layer is separate. So, it means so NAS layer is available in 5G or not? So my question
It
is
is no, it is available, and the functionalities of the control plane and user plane will be same only. Those functions will not be different. The only thing is that's why I haven't covered those basic concepts of the control plane and the user plane. Of course, in the because LT guys are working, so they are well aware about the functionalities, the concepts of the control plane, user plane. So the mechanism, the way of working will be same only. It is only that this centralized unit is split into two more units, CU, CP, CU, UP. This happens only in 5G and not in any of the traditional technology, especially for the 4G. So there is no difference in the performance of this control plane, user plane, or NAS or the PDCP. Those will be similar only. It is just, this 5G is getting more, it is providing you more liberty. It is just splitting up. That's why I just introduced these terms, network slicing and all that. Those parts will be same only. If you want, I can just add if you want me, then I can add the control plane, user plane functionalities also before sharing the slide deck with you. Because I was under impression that, the participants having some basic fundamental knowledge. So kind of a prerequisite. If you want, I can add. No worries.
okay, sure. Can you please add?
Okay. Yeah, I'll add that.
Okay.
Don't worry.
Thank.
So running short of time, I'm just proceeding further because we have other topics to cover. Questionnaire we can discuss. Give me a moment. So radio components we have covered. So now coming on to our third topic, which is your core network elements of 5G, basically AMF, SMF, and the UPA. Give me a moment. Just be with me, guys. Yeah. So basically 5G, as I said, this is the service-based architecture, SBA. So talking about the core network elements, we have three core network elements in 5G, AMF, SMF, and the UPA. So I'll be covering one by one all these three core network elements. Starting with the AMF, AMF stands for access and mobility function. SMF stands for your session management function, and UPF stands for user plane function. So starting with the access and mobility management functions. Basically, these three core elements, they are the pillars that control your mobility, session creation, and the user traffic in 5G. So these are the functions of these three core elements: the mobility, session creation, and the managing the user traffic in 5G. So coming back to AMF, access and mobility management function. So this core element, it is responsible for handling the NAS signaling, non-access stratum signaling between your user equipment, handset, UE, and the core network. So it is the one which is basically handles the NAS signaling between user equipment and the core network. It acts as a central hub for the control plane communications, AMF. It is a central hub for controlling the for the control plane communication. Sorry.
Yeah, Gaurav, please share PPT on presentation mode.
Sure. Oh, sorry. Sorry for missing on. Is it better now?
Yes, now it.
Okay. Then talking about the key functions of AMF. Functions of AMF, it includes the registration and authorization of devices, access control, mobility management, such as facilitating the handovers, the connection management, the security assurance, and initial PDU session handling in cooperation with the SMF, basically. And this access and mobility function, it also authenticates the users, UEs. It authenticates the UEs to use the 5G services and enforces network access policies, ensuring secure and uninterrupted connectivity as users, because they move from different locations. So it ensures the seamless connectivity, and it authenticates a particular user to use the 5G services. This is for the AMF. Going to this AMF slide. Now there are some key interfaces of this AMF core element: N1, N2, N8, N10, and N12, basically. So basic description I already mentioned in this slide. Like N1 interface is meant for NAS signaling via the G node B. N2 is responsible for managing the control plane operations. N8 is for subscriber data, and rest N10 and N12 for indirectly through NRF and SSF. These are the few of the key interfaces which I have included in this slide. If you want further, I can just add a slide of detailed explanation of these individual interfaces. This is just to give a basic idea. So basically, our access and mobility functions, it ensures the seamless connectivity, and it allows the user to register into the 5G network. Now going to the next core element, which is our SMF and the UPF, starting with the SMF, which is session management function. What are the functions of session management functions? It is in charge of managing the PDU, packet data unit session, and orchestrating the session-specific network elements such as UPF, PCF, UDM based on request, and it receives from the AMF. So AMF just it used to receive the request from AMF, and it is used to manage the PDU sessions, all the PDU sessions. And the basic responsibilities for session management functions, it used to create, modify, and release the PDU sessions. The packet data unit, it used to create, modify, and release the PDU session, assigning the IP addresses to the resources, and enforcing the policies, and directing session update for UPF via an N4 interface. This SMF also, it used to provide the seamless data connectivity, data session management, and it used to bridge the bridge between the control plane and the user plane, and within the 5G core. So these are the basic functions of SMF. And unlike for the AMF, SMF also have some interfaces: N4, N10, N11, and N7. So these are some of the functions of SMF. Now talking about the third core component, which is UPF, user plane function. Why user plane function is used? This is UPF is the primary anchor point in the user plane. As the word signifies, the user plane function, it is the primary anchor point in the user plane of the 5G core. So because it is the first anchor point, so it handles all the user data traffic operations. This is for directly handling all the user data traffic operations. And further, what it do? It forwards, routes, and processes the data packets between RAN, basically the G node B, and the external data networks. It applies packet routing, filtering, QoS, quality of service informants, and session-based traffic management as per the policies received from SMF. So these three components are interconnected. Every core element has some different functions. Every core component has some different interfaces. And UPF, this user plane function, this is the core element. This is the one which enables the CUPS, controlling the user plane separation. It allows flexible and efficient data handling for each session established by the SMF. And unlike all those other components, this UPF also have some interfaces: N3, N6, N4, where N3 handles the user plane, N6 is for internet enterprises, and N4 is for SMF. It receives, this is the interface, because UPF, through which interface it receives the requests and the messages through SMF. That is the N4 interface. So in the overall workflow, this AMF core component, it manages your control and mobility aspect. SMF is the one which orchestrates session establishment maintenance. And last but not the least, the UPF. It processes and routes your raw user data between the device and external networks. So together enabling the seamless and scalable operation of a 5G network. So this is how it goes, basically. Let me see whether, yeah, this is the short summary table. It gives a better idea. Just a very basic, very short summary table in which I have mentioned the names of those core elements, AMF, SMF, UPF, which plane they are situated, like AMF, SMF are on control plane, UPF is on user plane, as the word signifies, user plane function. Basically, the major roles in a very, short terms, and the interfaces involved in it. Give me a moment. No. So once again, coming back to the slide. Yeah. So this is the short summary table. If participants want a detailed explanation of each and every interface, I haven't added them here purposely due to the shortage of time. But if participants want, before sharing this PPT slide, I can add the individual explanation for each of the interfaces. I can do that. So please ask if you want. I'll do. If the concepts are clear to you, we can keep it.
Please add the slides, sir.
Sure. I'll add. Thanks for confirming. I'll add those. Of course, this is a 1.5 hour session, so purposely I haven't included those. I'll add that. Now going to our fourth topic, our first module, that is the functional splits. Basically, CUDU functional splits, CUPS architecture. Give me a moment, guys. Okay. So talking about the functional splits of 5G. So 5G, it uses a disaggregated RAN architecture. Disaggregated means distributed. So this functional splits, this 5G, as I told, that it is comprises of CU, DU, and RU, the central unit, the distributed in this radio unit. So this division, this disaggregated architecture, it enables your virtualization, low latency, flexible deployments, and for the cost optimization. So by splitting up, this provides so much of advantage, this 5G, that it enables to create the virtual network. It helps to run the operations which are on low latency. It provides the flexible deployments. That part also we covered, and this is the cost optimization basically. So we have some of the functional splits basically. There are three kinds of functional splits in 5G RAN. Option 2, option 7.2, and option 8. So individually we will be covering all those. So talking about this option 2, this is the very high level split. And where it is situated, it is located between the CU and the DU, the central unit and the distribution unit. So talking about this as a option 2. This option 2, this is the one which is more widely used in the functional split. And why it is widely used? Because it has some advantages. It has some distinctive advantages. This option 2, it is used for the enterprises, means for the private 5G. It is used in the smart factories. It is used in URLCC, robotics basically we talk about. It is used in network slicing. It is used in low latency apps. And it is also used in VoNR rollout, voice over NR rollout, basically. So network slicing, URLCC, VoNR, MEC, SBA core, smart factories, private 5G network. For so much of tremendous advantages, this is the popular or the widely used functional split, the option 2, which is situated between CU and the DU, basically. This option 2, which is located between CU, DU, it further split at the PTCP RLC boundary. it gets further split into the PDCP RLC boundary. And as I said, this is like most widely used because of, and few other advantages are there for this option 2. It is having low front haul bandwidth, very low front haul bandwidth. And this central unit, it can be centralized and virtualized both. It is located in the cloud platform. So we can make our network as centralized or the virtualized. And DU, as I told, that this distributed unit, which is located near to the cell site, it is having very low latency. So for the option 2, we have two kind of interfaces. One is your F1C, which is the control plane, and another is for F1U. Because already this your central unit is being split into CUCP and CUUP. So we have individual interface, one for control plane and one for the user plane. So talking about option 2, function split, we have two kind of interfaces, F1C, that is meant for control plane, and F1U, that is meant for the user plane. So this is about option 2 only. The advantages also I have listed. Going towards the next function split, which is the option 7.2. Now this 7.2, it is situated between DU and the RU. It is situated between the DU and the RU. And this gets split inside the physical layer. This gets split inside the physical layer. There are some variants of this function split, 7.1, 7.2, 7.3. We just, as per the ORAN Alliance standard, we have option 7.2. Now, what are the advantages of it? This 7.2 split, it allows your cloud RAN operations. This is the one which allows your cloud RAN operations. It is having lower latency as compared to option 8. Next function split is option 8. So as compared with option 8, we have the low latency in option 7.2. And this is the function split layer which supports your massive MIMO with very good efficiency. This is the one which supports the massive MIMO. Now the interface, it has one interface which is called as Open Front Haul Interface, ORAN. Open Front Haul Interface, eCPRI is used being on Ethernet. So this is for the 7. Somebody asking something. Is somebody raise hand? No? Okay. Guys, if you have any question, any point, please say in between. Otherwise, it will be like, monotonous kind of session, which I don't want. So last but not the least, the option 8, functional split, it is situated between BBU and RRH, the baseband unit and the radio resource head, RRH. This functional split, it is having very, very high bandwidth. It is having very high bandwidth, and it is used in latency LTE CRAN, centralized RAN basically. So talking about the option 2, which is the most widely used, the commercially which is used between the CU-DU, the PDCP, packet data convergence protocol, it is in the CU, RLC, MAC layer, physical are in the DU part. So the central unit is holding PDCP layer, and this DU, distributed unit, sorry, not the distal, distributed unit handles your RLC layer, MAC layer, and the physical layer. So this is how it goes. I might have added one summary unit also. No? Yeah, this one. This is the summary slide. For the ease of the participants, I have just added one image also. In this image, you can see three kind of our functional splits, option 2, option 7.2, and option 8, which shows how it gets split, where they are located. Of course, the advantage I have already listed. And right side, which you can see between which particular components they are located, and what are the interfaces for them, and what are the purposes of them. Advantages I have already included, I've already conveyed. Of course, slide deck will be provided to you. So advantages and all already mentioned in it. I am emphasizing towards option 2 again and again, because it is the one which is being massively, it is one of the most popular split, which is being used by the operators. It is most widely used for both 5G standalone as well as non-standalone architectures, SA rollout and SA rollout. It is having lower front haul bandwidth, and this central unit runs on cloud. In option 2, central unit runs on cloud, centralized, and this distributed unit handles the centralized operations basically. Well, 7.2 This is in the lower physical and distributed unit, upper physical unit in the radio unit. As I told earlier, the 7.2, it handles the massive MIMO. And basically it requires less than, like we can say, less than 250 microsecond latency. And last but not the least, the legacy CPRI option 8. It is used in LTE centralized RAN. But this is, option 8, the last one, it is not preferred for the 5G. Why? Why it is not preferred for the 5G? Because it is having very high front haul bandwidth. So if we operator use the front haul bandwidth, of course, the resources will be more, the cost involved will be more, it will be tough to manage. That's why, because of the low front haul bandwidth, option 2 comes into play. It is being widely used. So by this, we covered our functional split in 5G. The CUD were 3 options which I have mentioned. This is for the functional splits. Let me see for the next slide. Okay. Until this split part, any participant have any question, or we can proceed for our next topic, which is the interfaces of 5G. Can I proceed? Anybody having any suggestion, any point, any query? Or I can proceed further? Anybody can confirm, please?
Hi, I have some other question, but it's not related to this topic. I think I will ask at the end of your session.
Yeah, sure. No issue. You
Thank
can ask them between also, or if you want. Okay, you can ask at the end. So we are running short of time. Let me go towards the 5G network interfaces. We have some of the interfaces in 5G. Give me a moment, guys. So yeah, on the slide which you on this slide you can see we are having the 5G network interfaces. We have total of 5 interfaces: NG interface, E1 interface, F1 interface, XN interface, and the X2 interface. I'll be just covering each and every interface, the description, what are the functionalities and all, one by one. So start with the NG interface. So what is NG interface? First of all, this NG interface in 5G, this is used between the G node B and the 5G core. This interface connects your G node B with the 5G core element. So this NG interface, it is further divided into 2 parts. One is NGC, another is NGU. NGC stands for your control plane, NGU stands for your user plane. Talking about NGC, the control plane, this interface connects your G node B with the AMF, access and mobility function, the core components which we covered in the previous slides. So this interface connects your G node B with the AMF. What it do? This NGC, or the control plane, it carries your control signaling, registration, session management, mobility, paging, and etc. All those operations. Means it controls the signaling part, registration part, session management functionality, mobility part, and the paging part. While if you talk about the NGC, that is meant for the user plane, this interface connect your G node B with the UPF, user plane function basically. This interface connects your G node B with the UPF. What it do? It carries all the user traffic, data packets basically. Further functions I have mentioned, like QoS, flow handling, packet forwarding. So on the whole, we can say that it handles all the user data traffic, all the data packets. This is for the NG interface. Going to the next interface, which is E1 interface. E1 interface, this is used inside the G node B between CUCP, CUP. As I told, this central unit, which was further split into the user plane, and the control plane. So basically, this is located inside the G node B between the CUCP and the CUP. And further, it is having 2 components, E1 C, E1 U. Because of the split architecture, every interface is divided into the control plane and the user plane. Talking about E1 C, which is for the control plane, so it handles the signaling between CUCP and the CUP. And while the E1 U, that is the user plane, it handles all the user plane data path. This E1 interface, it is very less commonly discussed because since user traffic is mainly via CUP, UPF, it is very less commonly discussed interface. And this E1 interface, it manages user plane setup, bearer configuration. And the below, I have mentioned one key benefit of this interface. This enables flexible deployment, where CUCP handles control logic centrally, and this provides the interface provides a flexible deployment. So this is for the even interface. Going towards our next interface, which is Axon or FN. This is Axon interface. Axon interface basically, this is used for the inter-G-node B communication from one G-node B to another G-node B. BTS to BTS, you can say, or E-node B to E-node B. But in 5G, we will always be using term as generation next G-node B. So this interface used to connect between the G-node Bs only, from one G-node B to another G-node B. So what are the functions of Axon interface? Axon interface is used for handover signaling. It is used for dual connectivity. Dual connectivity means like in the NSA deployment, NSA architecture, a non-standalone, which in non-standalone means the architecture uses both 4G component as well as 5G component, where the LTE stands for this one master G node B, while the 5G goes for the secondary G node B. So Axon interface is the one which is being used in dual connectivity, and this interface also used for load information sharing. This interface also used for the mobility robustness. And as talked about the early interfaces, because of the split architecture, this interface also gets split into two more components, one for control plane, another for user plane, that is Axon C, Axon U. These terms are very easy to remember because they are nothing but, every interface is divided into two components only, one for the control plane, one for the user plane, where this Axon C handles your control plane signaling, while the Axon U handles your user plane data forwarding during the handovers. So this is for that. And give me a moment. Last but not the least, it is the X2 interface, which is used in LTE as well and for the NSA deployment as well. So basically, this interface, the X2 interface, it's used for the inter-E-node B communication in LTE and between E-node B to G-node B in the NSA mode. NSA we talked about non-standalone mechanism architecture in which both of our technology being used, 4G and the 5G. So basically, to communicate from LTE to 5G, E-node B to G-node B, this interface being used, which is called as X2. So basically, and in LTE also, you might have heard about this interface, X2 interface for the X2 handover, S1 X2 handover. This is for ENDC dual connectivity, as I told, and this is used for resource status and the load sharing. For the load sharing, X2 interface being used. Further, unlike other interfaces also, this interface also is split up into control plane, the user plane, X2C and X2E, X2U, where control is for handling the control signaling operations. X2U used for user data forwarding during the handovers. So this is for the X2 interface. In each and every slide, I have mentioned this, control plane and signaling plane also components also. So this is we talk about the interfaces, and this is the tabular format for more ease, for better understanding. I put one tabular format where you can see each and every interface for which technology it supports. Like X2 is the one, only X2 interface is the one which take care of the NSA strategy. Other all meant for 5G only, and how and what components it connects, what are meant for the control plane, what is meant for the user plane, and the purpose. So tabular format I have added for the better understanding, basically on a very fundamental level. So this is about the interfaces. Now we have, in the first module, we have 3 more topics left with us. Now, 3 topics are like some key of the parameters like bandwidth, TDD, MIMO, the deployment strategies, and the performance KPIs. So let's start with the some of the basic key parameters like the bandwidth, TDD, MIMO, and the subcarrier spacing, basically. And I'm sure that this is not a new one. The bandwidth, TDD, MIMO, very fundamental terms. The SCS, subcarrier spacing. You guys are working on LTE. You prepare for the interviews also. You for the knowledge enhancement also. You read various docs, watch various videos. So these are the terms which you come across every day and night. So there is nothing in that. But I haven't skipped it. I have added them purposely, although you might have known, but it is better to, better to revise some of the key concepts so that some essential things not get missed. So basically, this is the tabular format which I have put, because these are the terms I haven't spent much of the time. Still, I have, as a summary, I have put as parameter, this is bandwidth. Bandwidth is nothing but the frequency span per carrier. These are the typical range which I have mentioned. These are the impact on performance, which I have, as you know, that more is the bandwidth, higher is the throughput. And like the duplex mode, how basically downlink and the uplink spectrum being shared. This is the MIMO, multi out 5G. We have massive MIMO, basically 2x2, 8x8, and 64x64 is the highest one, MIMO configuration, massive MIMO, which 5G have faced. Basically, MIMO is the one which improves your capacity, it increases your efficiency. And last but not the least, the sub-carrier spacing. Anyone anyone can just give me a basic definition. What is sub-carrier spacing? Just in order to make this session interactive, because this is not the new term, guys. This is not the term which is being used in 5G only. This is the very traditional, very old term. Any of the volunteer can just tell me what is sub-carrier spacing. What do you understand by sub-carrier spacing? What it defines? Anyone can, please. What do you understand by sub-carrier spacing? Come on, guys, just speak out. Session should be interactive. No? I hope I'm audible.
Yes, audible.
Okay. So it's okay. Anybody wants to say else, it's okay. So basically, this SCS subcarrier spacing, this defines the frequency operation between adjacent subcarriers in an OFDM base symbol. I mean, like LTE or 5G, we can say. So this defines the frequency operation between adjacent subcarriers in an OFDM based system. So it directly affects your symbol duration, latency, and performance under mobility. It is the one which affects your symbol duration, your latency, and the this performance under mobility. So this is for the subcarrier spacing. For LTE, we have very fixed subcarrier spacing of 15 kilohertz, but in the 5G, we have liberty of setting up the multiple SCS, like starting with the 15 kilohertz. It goes up to 15, 30, 60, 120, or the 240 kilohertz. Just one minute.
Sir, how much are we used in 5G?
Sorry?
Sir, how much RV resource block used in 5G?
You're talking about the maximum resource block? Guys, just 1 minute. Please give me a moment. Yeah, I'm sorry. Just missed the part. Can you please come back with your question? What's the question? Sorry for this gap. Come again, please.
How many RBs in 5G is asking?
Okay, maximum RBs, resource block in 5G. See, it depends on some of the factors like the channel bandwidth, sub-carrier spacing, like whether you are using your RBs in FR1 or FR2. So it depends. So basically, I can say for frequency range 1, max to max of resource block in 5G, they are around 273. If you use of a bandwidth of 100 megahertz with the 30 kilohertz of subcarrier spacing, so maximum resource block which comes is the 273. And talking about this higher bandwidth, like for FR2, frequency range 2, higher bandwidth, for example, if using a bandwidth of 400 megahertz with a subcarrier spacing of say 120 kilohertz. So the maximum RBs will be around 264. So that depends. What are the frequency range you're using, and what is the bandwidth and the subcarrier spacing which you're using. So example for the FR1, if you use like 30 kilohertz subcarrier spacing with 100 megahertz bandwidth, you can expect a maximum resource block of 273. While for the FR2, where you're using the subcarrier spacing of 120 kilohertz and bandwidth you're using of 400 megahertz, sorry, you can expect max to max of RBs of 264. So this is how it goes. So it depends on, channel bandwidth. It depends on the how much subcarrier spacing you're using, and it depends the frequency range you're using, FR1 or FR2. I hope that answers your question.
Yes, got it. Thank you.
Okay. Okay. So this is for the key parameters. Bandwidth. Further, I have just mentioned the short description of bandwidth, MIMO technology, subcarrier spacing, TDD, and TDD FDD pressing. Guys, in this slide, there is nothing much to discuss. I expect at least this much of fundamental everybody must be having. But purposely, I have added one slide of the short description of these key parameters as well. The slide will be shared. You can go through it. Moving further, now talking about the few of the key parameters, basically. No, sorry, this is the same slide. Before discussing some KPIs, I would like to go with the deployment options. We have few of the deployment options in our standalone network as well as non-standalone network. Few of the deployment strategies I would like to discuss here. So this is the basic difference between the SA and the NSA deployment. So there are some key differences between those. Like if I talk about the core network. So non-standalone network, this core element, it is having the 4G LTE EPC, enhanced packet core. And standalone only uses the only
Hi.
5G. Sorry.
Hi, I have a questions. I'm sorry, I missed some of. Maybe I'm completely confused about the number of. I have a questions if the number of the subcarrier per radio resource block is fixed like as in LTE. What we know is that 12 subcarrier per LTE resource block, which means the resource block occupies 180 kilohertz. So I know that is the spacing, carrier spacing or subcarrier spacing in 5G is varies from 15 to 24. But what about the number of subcarrier per resource block in 5G? Is it fixed like 4G or it also varies?
No, it also varies. It also varies because you have a scalability, you have variations in subcarrier spacing, you have variations in bandwidth as well. So both of the fundamental, components having so much of variation. So bearer is also not fixed, unlike LT. This also varies.
Even the number of subcarriers or the FDM symbols per radio resource block.
Sorry, come again.
Also, yeah, I know the bandwidth. The bandwidth itself it varies if it is in frequency range 1 or in frequency range 2, and also about the sampling rate or the spacing between for the subcarriers here. But what about the concept that it is fixed number? I think in 4G it is 12 subcarriers per resource block. Is it similar in 5G to have just 12 subcarrier per resource block?
No, it is not fixed. It varies. It is not fixed. It varies. It varies with the bandwidth. It varies with the subcarrier spacing. It varies with the type of service you use. It varies. It is not fixed kind of thing.
Thank you.
Yeah. So can we proceed further?
Yes, please.
Okay. So we are just continuing with the deployment strategies. So basically, for NSA, SA, the deployment speed in non-standalone, the deployment speed is very faster because it leverages, existing infrastructure being used in NSA. While SA, the deployment strategy is very slow and it requires a new core element because in 5G you're using only 5G core element. But in NSA, non-standalone, you are using the existing LT architecture. So the deployment is fast, cost effective. Talking about latency, jitter or delay. Latency we talk about in NSA, it is very moderate because it is limited to LT only. While in the 5G, the latency is ultra low. That is the very great advantage in 5G. And because of the ultra low latency, it is being used in the applications like URLLC support, ultra low latency operations being used. This is the advantage. Talking about the features. Features basically this network slicing. Network slicing don't exist in LTE. Network slicing, as I covered it earlier, network slicing is only included in 5G. It has no relation with 4G. So basically talking about the features, enhanced mobile EMBB services that is being used in LTE, but in 5G you are having MMTC or full NR specifications. They are the features. Talking about the power efficiency. Power efficiency in non-standalone, it used to consume the higher power because of the dual technology. In NSA, you're using LTE as well as 5G, the power consumption will be higher. While in 5G, where only single technology being used, the power is more efficient. Talking about the use cases, LTE is for initial rollout for the coverage expansion, while for the 5G, the standalone 5G only, this is used in enterprises, private 5G network, the IoT. This is the future-proof technology for the 5G. So this is basically the difference between the NSA and the standalone features, some of the benefits, some of the limitations. Now talking about the deployment strategies, we have few of the deployment strategies in SA and NSA modes. So basically this table comprises of, this table describes those of the deployment strategies. We have few options of deploying our strategies, like option 2, which is the most commercial one. Sorry. The option 3 is the most commercial one. For the 3A, 3X. Option 3 is the one, this deployment strategy is being widely used among all the operators. I'll tell you why, what are the benefits. So we have total of 6 deployment strategy, starting with option 1, 2, 3, 4, 5, and 7. 3 is split up into 3A, 3X. 7 is split further into 7 is 7X. So in this table, you can see which deployment strategy is specifically meant for SA rollout, and which option deployment strategy is meant for the NSA rollout, basically. So this table comprises of all. So this is the deployment tab, like for option 1 is for 4G only, option 2 is for 5G only, and option 3 as well as option 7, these are the both deployment strategies, option 3 and 7 that is being used for 5G NSA. But option 7 is for your future ready. This is not being used as of now. As of now, on commercial point of view, option 3 is the one which is being used in 5G NSA. Option 4 also is the future ready technology, while for the LTSA standalone, option 5 comes into play. It is very rarest of the rarest being used, option 5. So basically, if we talk about the non-standalone NSA deployment strategy, the NSA in 5G, it shows how this 5G NR, the G node B, coexists with the LT E node B. And the control plane, this control plane remains on LT EPC basically, while the 5G NR is used mainly for the user plane data, enabling quicker 5G rollout without a 5G core. This is for the NSA, where existing resources being used. It is for the faster rollout. So basically, where NSA, there is a coexistence between the LT and the 5G. While talk about the standalone, SA, this highlights a pure 5G architecture, pure 5G architecture, where this 5G NR, basically G node B, it directly connects to the 5G core with no LTE dependency. And this SA, it enables full 5G features like network slicing, service-based core, low latency, for the better QoS services. So this is for the SA NSA. Now coming on to the deployment strategies. So again, if we talk about the NSA option, non-standalone option. So non-standalone option, what are the options which we are having for NSA rollout? First option is option 3A and the 4. So basically NSA leverages existing 4G infrastructure for rapid rollout. Now this option 3 in which dual technology being used, which is the most widely being used, in which the master unit is for the LTE technology and the secondary unit is for the 5G NR technology. The evolved packet core X2S1 interface for ENDC dual connectivity. Furthermore to this, we have 3A, the sub-deployment option. This 3A, what it do? One enhancement is there in this 3A, it adds bearer split for NR user plane. It adds a bearer split in the NR user plane. Continuing with the NSA, we have option 4 as well. Here in the slide, I have included this option 4. In this, your NR, the 5G becomes your master unit, the LT tech, it becomes a secondary unit. But it is very less common. It is having EPC core. And this prioritizes EMBB by NR capacity boost on LT control plane. But this option 4 is very, very less used. you can say that it is not meant for the commercial rollout, basically we can say. So option 3, 3A and the 4 meant for the NSA deployment. Not talking about the SA options, standalone options. Standalone options, we have options 2, option 5 and option 7. SA means, as I told, that it enables all the 5G features. So option 2, option 5 and option 7. This option 2 is purely for the where where an G node is connected to the 5G core via NG interfaces. Interfaces we already covered in our previous slides. So option 2 is basically the G node be connected to 5G core via NG interface. It supports slicing. It supports your ultra low latency operations. It supports your MMTC features. Then comes for option 5. Option 5 means NR plus LTE to the 5G core. This is hybrid for the coverage. This is hybrid for the coverage. This is for the E-Ultra or the NR dual connectivity. This is for the standalone option. Obviously, for any of the random operator, first it goes with the NSA deployment strategy. After just user penetration, after attaining a certain number of users or the market, it used to migrate with the NSA to SA operations. So SA operations, as I told, option 2, option 5, option 7. This option 7 is meant for ANR, for accessing radio. This is not for the automatic neighbor guys. This ANR stands for access network radio unit. This is for the option 7 slide which I have included in this. This option 7 in SA mode, this is ideal for the advanced RAN, means CU/DU split in any of the workflows, and it is flexible for the LT/NR mix kind of thing. So basically, this option is for the 5G advanced, we can say. This is not still, it has not come into picture. It is in the deployment strategy, but that is not being used because of the 5G advanced. It is meant for the 5G advanced deployment option. I missed one slide, I think. No, I haven't missed anything. So basically, separately, I have mentioned here the deployment reality. Like for the option 3, NSA enables operators to deliver 5G services quickly while maximizing return on the existing 5G infrastructure investment. Because of the scalability, because of using the existing resources, the amount of the investment, which one operator do, this is the deployment strategy which used to return the investment on a very faster pace. That is why it is the most popular, the favorite of all the operators. As of now, you can research, you can just, you can go through various of the learning portals. You can see that option 3 is the one which is most widely, which is being used widely. And here I have just differentiated this NSA versus the SA deployment strategies. This part we have already covered some of the aspects like core network, deployment speed, latency, some of the use cases. And this is the tabular format in which I have mentioned about the deployment strategies, for which mode it meant for NSA or SA. The core element being used, obviously, as a common sense, in the NSA mode, enhanced packet core being, evolved packet core being used, EPC. And for the 5G operations, 5G operations, 5G core being used. So I have just made a tabular format for better understanding of you guys. And like talking about, operator cannot just run on the NSA path. It has to migrate its network from NSA to SA. So when that step comes, so how this NSA to SA migration path being followed? So basically what operators do, operators migrate from NSA to SA by gradually introducing the 5G core. Because unlike in the NSA, in which the core of LT, the old technology, the traditional legacy technology being used, but when a particular operator goes from NSA to SA, it used to introduce the 5G core alongside the existing EPC. So what it do, it enables the hybrid operations before fully rolling out the standalone mode, often following the 3GPP options like 3x, 7x, 2. So basically, this is with the introduction of the 5G core. Now there are some of the migration steps of migrating from NSA to SA. We have few of the migration steps. We have few phases: phase 1, phase 2, phase 3. In the first phase, NSA option, because let us suppose one operator is using the NSA 3x option, 3 option basically. So what it do, where it deploys the NR as the secondary node and LT is the primary node. So this is your first phase in which the X2 links being used. Now it goes in the second phase, phase 2A, in which hybrid NSA to SA takes place. Here, the introduction of 5G core parallel to EPC with N26 interworking for handovers takes place. This phase 2 is divided into phase 2A, 2B, and then comes into phase 3. This migration part, I haven't purposely included in this slide because we are talking about the deployment strategies, deployment options. So I just don't want it to confuse you guys with those migration steps, because obviously, first you understand about the NSA and the SA individually first. Then we will go towards the migration path. This migration step I can cover in the rest of the modules also. It was not so necessary that I could have included in the very first module. That's why I haven't included that migration path slides in this slide. We can discuss it about later on also. So basically, in NSA, what we are doing, we are upgrading our LTE sites with NR, faster rollout. We have our theoretical options. In SA, we will be having our fully 5G ground network for enterprises and for the low latency use cases. Now, hold on. Guys, just give me a moment. Yeah, okay. So talking about these deployment strategies, NSA, SA, the strategies the options which we covered, where they are located, what are the benefits, what are the basic difference between NSA and SA. We are heading towards our last topic, but before that, anyone having any doubt in these deployment options which we have covered, specifically for the deployment strategy which we covered? Anyone having any doubt before proceeding towards the KPI part? I'll take a pause because I want to ask any of the volunteer, any of the participant want to add something, want to suggest something, want to ask something, or want to say something. Else I can move further.
I have one question. Actually, we just like to NSA to SA deployment. We understand we need to cover, means we need to modify or upgrade for the core site. So is it any way, or there's any option to modify in the G node B sites? Because core side we're going to modify. Without modify for the core side, we can't deploy an NSA to SA. So there's any way or anything need to be modified from the G node B sides?
There are a few factors for it. First of all, you have to replace your existing EPC, the evolved packet core, with the 5G core, because ultimately, it is the core, it's the brain of the network, the core element. First of all, you have to replace your existing EPC with the 5G core, the first thing. The second thing, talking about you had mentioned about the G node B. Definitely, the hardware which you are using, that should be 5G ready. Many of the vendors already have their equipments with 5G ready. And in that 5G ready hardware, you have to run the software packages.
Okay. Only for the software need to upgrade.
Definitely, because already this is, cloud-based technology. It is not a flat or a hardware-based architecture, unlike in the LT. This is cloud-based. You are using the edge computing. You're using this. You have already made your split and all that. Your hardware is ready. So you just have to run the software packages.
Okay.
You have to features. You have to run. You have to upgrade with the help of some features and the software packages, and your network will be. But there are phases for it. We are just talking, but there are phases for it. This is not a very straightforward, or a so similar manner. This is just for the discussion. But yes, we had to make changes not only from the G node B, but from the core part as well.
Yeah. Thank you. I got it.
Yeah. Thank you. Thank you so much. Thanks for the question. So moving towards our already running short of time, but still it's okay. So we are heading towards our last topic of this first module. This is the most challenging and the most exciting part. That is the performance KPIs. KPIs like accessibility, retainability, mobility, integrity. Modus operandi is similar in some manner, but there differs in other manners. So why, in 5G, how it differs, that I'll be covering. So basically this, the term, the meaning, what KPI is meant for which thing, you guys have already known. Like accessibility, if I talk about this accessibility, it measures the success rate of users gaining services, access after request, probability of receiving and proceed to select a signal. How you access the network. How one user access the network. This is for the accessibility part. Talking about retainability, this retainability, what it do, it evaluates the service continuity without drop rate, radio link failures, frequency. and involuntary detachments. That is for the retainability. Talking about mobility, the mobility is nothing but evaluating the network ability to maintain the service during the user movement, handover procedures, basically, mobility. And last but not the least, the integrity part, like to assess and service quality during active sessions, focusing on throughput, latency, packet error rate, and the spectral efficiency. That is for the integrity. So terminology is common. Terminology is common. So proceeding with the discussion of the KPI individually, basically. So let's start with it. This is just a small table. So we have divided our KPI segment into four sections: accessibility, retainability, mobility, and integrity. Okay. So talking about accessibility first, accessibility is nothing but it refers to how easily a user can access the network services. Basically accessing, RRC, RAP, ERAP, PDU session, voltage services and all that. How basically user can access the network, that is for the accessibility. And KPI for the accessibility, many of the KPIs are similar. Threshold can vary, like RRC connection setup success rate, ERAT DRB setup success rate, attach registration success rate, call setup CSSR, call setup success rate. But we have introduction of an additional KPI in accessibility, that is the PDU session establishment success rate for the 5G only. The PDU session establishment success rate. This is the introduction of a new KPI in accessibility part. Now talking about the accessibility failures. In 5G, what are the, in terms of accessibility, which you may encounter? That is the rash failures first. Second is the poor coverage. Third is the congestion at the control plane. And fourth is the parameter misconfiguration, basically. One is the rash failure, poor coverage, congestion in the control plane, and fourth is the parameter configuration. So typical KPIs, as I conveyed, this is the RRC setup success rate, ERAB or the DRB establishment success rate, voltage SIP invite success rate, and last talking about the PDU session, that is the paging success rate, basically. This is for the accessibility part. These are the accessibility KPIs which I have mentioned. Below this, you can see in this slide the common failure cause codes. I have just summarized in one slide in order to consume less space. Otherwise, the slide deck will become more. This is the accessibility part. Now talking about the threshold. Threshold, you already know, this is having no much difference as compared with the LT. Like if I talk about the RRC success rate, the threshold by most of the operators is greater than 99%. Basically, RRC success rate, the factors which affects your RRC success rate, those are the coverage, like for the T300 failures, timers you have already gone through in the LT concepts. So coverage and T300 failures are the factors which affects your RRC success rate. Talking about RAT success rate, most of the operators having a threshold of greater than 98%. Depends, 98% or 99%. I have taken here as 98% of threshold. So the factors that affect your RAT success rate are your interference and the timing advance settings. Interference as well as the timing advance settings. If I talk about go to the next slide, DRB success, here I have mentioned the threshold also. Talking about DRB setup success rate, the threshold should be greater than 99%. The factors that affect the DRB success rate are the resources. I mean, if you're not having the adequate number of resources, your DRB success rate will degrade. And the QoS mismatch, in case of the quality of service mismatch, it also leads to the degradation in the DRB setup success rate. Talking about the NSA accessibility, the threshold should be greater than 98.5%, or you can say as close as 99%. The factor that affects your NSA accessibility success rate is the ENDC addition success. The feature of ENDC, if it works properly into your network, your NSA accessibility success rate will be more. If the ENDC doesn't function properly for a particular site or like n number of sites, you may face degradation in NSA accessibility success rate. This is for the accessibility KPI. Moving towards the next, the retainability. So retainability, what it do, it measures whether the network can maintain an ongoing session or call without being drops. Drop term, which is the most painful areas for all the operators, all the users. Nobody want to face the situation of a call drop, because you guys have Most of the guys might be working in LT technology. So in day-to-day calls of customers as well as our internal calls, it is very crucial to maintain the drop rate that comes under returnability. So basically the KPIs that comes under the returnability are your call drop rate, ERAT drop rate, RRC drop rate, voltage call drop rate, and we have an additional KPI for 5G in returnability, that is a PDU session drop rate. The PDU session drop rate. So there are the failures which you may encounter in terms of returnability are the radio link failures, RLF failures, bad handovers, poor handovers, the coverage holes, and the interference, basically. So talking about further regarding the thresholds of the KPIs and the factors which affect these KPIs, we have 4 KPIs. Like if I talk about the first KPI, that is the call drop rate, threshold of less than 0.5%. Ideally speaking, this call drop rate should be as least as possible, but definitely a threshold, a figure we have to mention. So if I talk about the threshold of the call drop rate, that target should be less than 0.5%. And the factors which affect your call drop rate are your radio link failure, late handover, and the uplink coverage. If you have poor uplink coverage, your drop rate will degrade. If you have delay handover, too late handover, your call drop rate CDR will degrade. And if you have too much of radio link failures, your call drop rate will definitely degrade. Talking about the next KPI, which is your ERAT or DRB drop rate, the threshold should be less than 1%. And the factors which affect this ERB drop rate is your RLC maximum retransmission and the beam failures. If your radio link control having multiple maximum retransmissions, again and again it used to reiterate these transmissions, then ultimately it will hamper your ERAP drop rate, of course, and the beam failures also. The third one is the radio link failure rate. The radio link failure rate, the threshold is less than 1%. The target should be less than 1%. The factors that affect your radio link failure rate are the coverage holes and the mobility speed. The coverage hole and the mobility speed. Maybe I haven't included those. No, yeah, definitely. I have included those part also. You can see.
Yeah, Gaurav.
Sorry.
Gaurav, it's enough for today.
Okay.
Some candidate is not able to digest. Those are already registered. So it's
Okay.
enough for today. Guys, feel free to ask your query. In continuation, we'll continue the session by next Saturday, 8 p.m. to 10
Just
p.m.
one last time.
Feel free to ask your query. Yeah.
Thank you.
Yeah, yeah. So
I
continue. Sir. Yeah.
I think we just add on one more things like you said that call drop rate in a 5G. I think 5G is the data service. So
Yeah.
just include something like that. Just we talked about the call drop in LT. It means we talked about the voltage, not the LT. So I think we need to know how to go through the voice call over the 5G. Then we justify for the call drops. I think so.
Yeah, definitely, because it don't provide this is meant for data services only. And because it don't have any voice over services directly, that's why, the mechanism of VONR being used. Voice over. See, in 5G, we used to measure drop in 2 manners. One from the voice part, another from the data part. You're talking about the voice part, that is VONR, and the data is your purely packet data sessions.
Yeah.
The content which will be shared with you, it will having all the details of thresholds and all those factors that affect these KPIs. Yeah.
Okay. Thank you.
So similar IMS is placed over 4G for voice and in 5G for VONR. Any other question, Sanjeev?
Yeah, I just said that in between the training, I just saying that I have one question, but it is not related to the topic. My question is, if suppose that any operator they don't have a LTE, they want to SA networks all over the country or whatever. So how they get a benefit? Because the 5G coverage is very less because they're using the high frequency bandwidth. So coverage pattern is less. Of course, they're going to get a benefit in the urban area because they have a more peer utilizations. They are more latencies. But if you want to distribute your network all over the countries, then so I'm little bit confused about that. Everyone saying that okay, 5G is the more cost effective. Then how they most cost effective if you distribute informally all over the countries? It is because if you want informally network over the country, then you need a more unit, means more G node B as compared to 4G because due to their footprint is less.
See, rolling out this 5G solely, I mean, you're decided to roll out your 5G network only for the 5G network. That is the SA option, pan India or something else. It requires a lot of effort in terms of cost, in terms of hardware, in terms of everything. And initially, when a new technology comes, it don't have so much of user penetration. Ultimately, you're rolling out something, you should have that adequate number of users on your network, in order to get the revenue in terms of as compared with the investment you have made. So LTE having a good user penetration. If you use the same infrastructure for LTE, at least you must will be having those number of users on your network. So rolling out 5G, it requires enormous, effort, too much of hardware, too much of new site, new genome base and all this. And plus you have to place your 5G core. You are using the core part as 5G only. Already you are having existing infrastructure. So in order to go for the scaling, first you will use for NSA because that is the most cost effective mechanism. Then you do the migration from NSA to SA. As of now, only in India, only Jio is the operator which gone for the for the SA operation fee of the 8 to 9 circles. Otherwise, it is very, very, ultimately we have to follow approach of cost effectiveness. We cannot go merely like this. So most
Yeah,
of the
it's true. Even though any operators have existing LT network, they're not going to implement all over the countries. They implement just like where they have users, like a urban area or suburban areas, and might be very few sites in the rulers due to the government policy. That's it.
And because your infrastructure is now only one which should be ready, your handset must also be ready. Still, in
Yeah,
many of the areas are there,
that's
your
true.
handsets are not ready. So people having an impression of, we are getting a good data service in terms of LT. So why we go for this one 5G?
Yeah,
So these are some of
that,
the ground challenges, ground realities which we face. That is why, first operators roll out with the 4G network, then they slowly migrate towards the 5G network.
yeah, it's
So
true. It's true.
yeah. So already we have
Thank
consumed
you.
much of. Brajesh sir, are we good to close or any point you would like to add?
Yes, yes, you can leave if you want to go. So, guys, any question further? You can ask.
Sure.
Okay. Those who are already registered, it's good. Those who wants to get registration for this course, you can ping on WhatsApp. Our team will connect with you. Okay.
Okay.
Thank you so
Yes.
much. Thank you so much for giving a nice
Yes.
time.
Thanks to all the participants.
This will it will take 1 month, 8 session, and 16 hours scheduled module. Okay. So thanks for joining today's session. Thanks to Gaurav. Thanks Deepak. Thanks to all.
Thank you.
Thank you.
Thank you all. Bye bye.